Hi, this is Dr. Gulshan Sahani, your physics tutor, and today I'm going to talk about center of mass. Here the question says two particles are connected by a massless rod. The 2 kilogram mass is positioned at x is equal to 0 and 8 kilogram mass is placed at x is equal to 5 meters. Then you find the center of mass. So if we look at the general formula for center of mass, then our center of mass, R vector, is m1 position vector r1 plus m2 position vector r2 plus m3 position vector r3 and so on, divided by sum of all the masses, that is m1 plus m2 plus m3 and so on. So if we take only two masses, then the formula in 3 dimension is R center of mass equals m1 r1 plus m2 r2 divided by m1 plus m2. Now, if it is a single dimension, one dimension position, then the formula reduces to x center of mass equals m1 x1 plus m2 x2 divided by m1 plus m2. And if there are many masses, then it is m1 x1 plus m2 x2 plus m3 x3 and so on, divided by m1 plus m2 plus m3 plus and so on. This is when they are in one dimension only along the x-axis. And if they are only along the y-axis, then it is y center of mass equals m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. And likewise for z center of mass is m1 z1 plus m2 z2 and so on, divided by m1 plus m2 plus m3 and so on. So in this question, this is a simple question where there are just two masses sitting on the x-axis only. M1 is 2 kilograms, M2 is 8 kilograms. So if I use this formula, M1 is sitting at the origin, so its distance is 0, whereas M2 is sitting at distance of 5 meters. So I plug in these values here, x center of mass, that is distance of center of mass from the origin, is 2 multiplied by 0 because x1 is 0, plus 8 times 8 is the second mass, multiplied by 5, which is the distance on the x-axis, divided by m1 plus m2, which is 2 plus 8. So if you plug in these values of m1 x1 and m2 x2 and get the value of x center of mass, then x center of mass is 40 divided by 10. That makes it 4 meters. So if you have single dimension, one dimension position of particles, then you can use this formula. And if it's a 3-dimension picture, then you can use position vector r center of mass equals m1 r1 plus m2 r2 plus m3 r3, and all these vector sums divided by the total mass of the system, that is m1 plus m2 plus m3 and so on. Hope it should work, and you can work with the same formula for more complex problems where there are many particles in 3 dimensions, and you can find the center of mass of the system as such. Okay, I hope this will work. Thank you so much.